All right, all right, all right, all right. All right, we are live. I hope we're live. We're doing this LinkedIn Live with Startree. And my name is Viktor Gamov. I am head of developer advocacy here at Startree, and I will be your host today. Before everything start, going around, and we will have our awesome speaker join me. Write down in the comments if you can see us, hear us, everything is working because there's many things going on with the live streams. While you're doing this, I will introduce my guest. It's our own Hubert. Hubert, how are you doing?
Feeling great, Victor. Thanks a lot.
I see you coming to us from the Sartre office today. So, how you been?
Yes. Um, it's the one with, above ground.
Okay, the one above above ground. Okay, cool. I will remind you to share the screen because otherwise we will not be able to see your presentation. And this is gonna happen on the next screen. Again, folks, we're coming to you from the East Coast, from like Greater New York area. So it would be great to know where are you all coming from. And yeah, so we're gonna start it again. Hubert, I remind you, you need to share the screen in order
Yep.
this presentation to work. And we're gonna start. All right, all right, folks. We're gonna talk today, or at least I will be listening and maybe channel some of the questions to Hubert. And Hubert probably don't require introduction because if you follow us and follow work that we do here at Startree with regards to Apache Pinot, real-time analytics, and all this type of stuff, you probably heard about Hubert. And today he's gonna share some of the interesting topic. Um, it's about a deep store, how it works in Apache Pinot, what's the common misconceptions, and because people can get a little bit confused what the deep store is and what it does. And he will share some of the interesting take on how you can test it locally or somehow with special another open source project called MinIO. And with this, Hubert, its stage is yours. Again, I'm reminding you, if you have any questions, please write down in the chat, and I will be translating those questions afterwards to Hubert.
Great. Thank you so much, Victor, for the introduction. Really glad everybody's here today. Today's topic is about Apache Pinot's Deep Store. Um, so, just a brief introduction of what the Deep Store is. In Apache Pinot, and maybe in some other databases, you need some way of backing up and restoring your data in case there's some kind of outage, or you need to scale up some data, or some for some reason you've lost your data, or you're setting up some kind of disaster recovery. Pinot actually has this built in already. It isn't something you need to like set up outside of Pinot. It's built in inside Pinot, and it's called a deep store. And it's a permanent. Oops, my browser went away. Okay, hopefully you can still see this. Um, it's a permanent storage for segment files.
No, we
Segment
cannot see your
files in the
screen. You
package.
need to reshare it
Reshare.
again. Uh
Okay.
huh.
It looks like my computer timed out because I didn't touch it for a little bit. So hopefully you can still see it.
All right, so we are back, and you can, for now, you can have a full screen, yeah, because we don't need to see the terminal just yet.
Okay. Well, I'm gonna do things that kind of simultaneously. So
That also works.
yeah,
Perfect.
let me know if there's an issue. Um, so again, the segment files in Apache Pinot are the way Pinot serializes or stores its data. It has with it some information that allows it to perform queries really uh, low latency performance, right? Um, so when you do this, the idea here is for disaster recovery mostly, or just for scaling up and you need a way to distribute that data, these segments across multiple servers. Servers in in Pinot serve data. That's where the data lives. Um, so it would make sense that deep store is going to somehow be related to how servers serve your data. Um, One thing I want to make sure that there's tend to be some confusion with what deep store is. It is not tiered storage. So tiered storage is uh, yet very similar to deep store, but not basically in the. But deep store here is not part of the query path. Tiered storage is. So think about your data in, let's say, in tiered storage. If you were to query that data, the tiered storage will bring that data back up to you to be queried, and the broker will return that data back to you. Deep store is not that. It's not in the query path. It's a way to, again, restore segment files that were either lost or in the process of scaling up your Pinot cluster. Okay. Um, so as we go on, so Pinot supports these um, file storage systems for deep store. Notice that they are cold storage um, file systems in the cloud, and that's basically what Deep Store is a way to get to a data lake, store your segments, pull them up as necessary to give them back to a server to serve that data into your queries. Okay. So what is MinIO? MinIO is a way to mimic a lot of these cloud storage. It is a local data lake that you could run with your applications or testing, and that's what we'll be doing today. Is starting up MinIO along with Apache Pinot and writing uh, to MinIO or the Deep Store via Pinot controllers um, to see how that path works. Okay, so here's the path. So for real time, in this case, there are two ways to get data into the Deep Store. This demo is going to demonstrate the real-time way of doing it, but I'll also talk about how the batch side works. So in real time, you think of a real-time stream, right? And that goes to, say, a real-time server. This is a server within Apache Pinot. What happens is that segments just get generated in the server in memory, right? In memory. What happens next is those segments get uploaded into the controller. So there's all these like things in a way. Let's see if I can just. Well, it goes from the controller. It's responsible for sending that data into the deep store. This is a real-time use case for stream process or streaming use cases. For batch or offline, let's say you have some data in your local file system and you want to send it to Pinot. What happens is that when you do that, it loads it into it generates segments locally and then sends it directly to the deep store and notifies these servers by saying, hey, there are new segments inside the deep store, come get them, right? And in both cases, we will be using MinIO. Actually, we're just going to do it for real time, but MinIO will be, deep store will be implemented as MinIO. So in this demonstration, what I would do is just learn. If you're not familiar with the Pinot Recipes and Star Tree data, you could go into github.com/StarTreeData/Pinot Recipes. In there, you'll see a lot of recipes that you can run, all related to Pinot. In this case, the one that you want, the one that we're working with is called MinIO Real Time, and this is we're using MinIO as the deep store. Okay. I'm going to start the recipe really quickly. And this does use Docker and Makefile, so you can just type make recipe here, and it'll stand up the required instances in Docker containers. You'll see some logs here coming out related to MinIO, and I'll go over these logs so that you understand what's happening when it's running. Right now, it's waiting for Pinot to receive REST API calls so that we could move forward. What's happening is that it's building the entire recipe from scratch, standing up Kafka, Pinot, MinIO, etc. Okay, so it looks like Pinot is up. Now we're going to check to see if Kafka is up and running. And then from there, we will test out the Deep Store. So now it's streaming some events to Kafka. And then Apache Pinot is reading that information from Kafka and creating segments in Pinot, and eventually through the controller, again, this picture here, and then eventually into the Deep Store. All right. There's a few commands here I'd like to kind of show you so that we could, so that the recipe is all up and running right now, and I'll get back to that after I go over some of these configurations. So this is how you configure locally your MinIO. You're going to need a MinIO username and password. You can just make those up. And that's basically it. This is all the default values. And then you'll need to go to the controller configuration. Remember, back up in this picture up here, the controller in real-time use cases, the controller is going to need to communicate with the Deep Store and write segments. So it makes sense for it down here to have Deep Store configurations. And in this case, since MinIO mimics data lakes like S3, we can just use the S3 Pinot file plugin, file system plugin. So this allows you or Pinot to interact with an S3 compliant Deep Store. We're telling it what region it's in. Again, the access key. This is in here. There's a duplicate line in here, and equals and the endpoint. So this is where MinIO will be reading, and we'll go into that in a second. Here, you also need to configure the server to talk to the deep storage. If you go back up here, in the server, when there are new segments in the Deep Store, the server is notified of those new segments and needs to be able to pull those segments from the Deep Store into itself. So that makes sense that you would need the server to also have that configuration. Again, this is in there twice. Again, a way to interface is just S3, the region, very similar configurations that you would see from the controller as well, right? Then from here, we can start running these commands. These commands were actually already ran in the Makefile, but we'll do them really quickly just to get an idea of what's happening. Okay. Let's copy that. So this is all running in Docker. So we're going to look at the logs that have come out when MinIO was stood up. Notice that it's got an endpoint to it. So let's go to that endpoint. Copy that. And now we have a login. Remember, if you look back here, our username and password was the same, MinIO Deep Storage. Log in. And there's the Deep Store. This is a bucket that we've created. You go in there, notice that there are events. This happens to be the name of the table that we've created, the real-time table we've created in Pinot. If you click in there, there are your segments. Okay. Let's kind of walk through how that happened, right? What we do next is we need to create an alias, and this alias we're setting to be my MinIO, and this this allows us to reference our deep storage with this alias. So any subsequent calls to MinIO can just be used using this without having to retype all these configuration settings. So this is our alias to MinIO, my MinIO, and then down here we are executing some things. So we're just getting some information. Let's run this one. Let's see what it does. So it's got some information about where MinIO is listening, etc. Like, so just informational information, right? Down here is where we create the deep store. So we have to do this before we tell Pinot it can start using this deep store. So we need to create this bucket, and the name of the bucket is deep store. MB here is I believe is make bucket is an alias for that command. What that does, this is the output of that command. I'm not going to do it here since I've already created that bucket, but we do this automatically in that make file. And I'll share that make file in a second. Here we're listing the contents of the make file, or sorry, the bucket. So if you copy that, paste that in here, you'll see it's got the deep store in it. In fact, you can just keep, drilling down into this deep store. You'll see that it corresponds to the path in here. We have deep store here and events here. Let me make this bigger here. I can continue this down, deep store, events, which is my table, and there are my segments inside the deep store. Okay. So let's validate this, right? So let me open up a console to Pinot, and we have a table in there called events, right? And we selected 10 records from it. Total of 1,000 records went in, and this is just a preview of the contents of that table. So let's delete. Let's go into the server. The server is the thing that holds the data. Let's look at the server. Let's delete the segments out of that server. So here I have a target or command that goes into the Pinot server and lists all of the contents of the index. It should map one-to-one with what's in the deep store, but I'm going to do it anyway. Clear. So this is recursively loading. Let me just do it this way. This is cleaner. Docker exec. So Pinot server. So I'm listing the contents of the Pinot server, and there's the subdirectories that contain the segments inside Pinot. What I'm going to do is delete them all. In fact, I'm deleting all segments related to this table events real-time events. So let's do that. Make delete. The command is. So now let's again list the contents of that directory. notice there's no such file. I mean, in fact, I deleted this entire directory real time. So there's nothing in it at all. So if I go make list, you'll see that the index is directory is completely empty. Let's go back to the Pinot and see how it was affected. Let's run this query again. Notice nothing's happening, right? So it's loaded these segments into memory, and you can still query them. And nothing's happening. I can change this to limit 100 and still get more of the data. So clearly, deleting the segments didn't affect Pinot. It's loaded that into memory, but now obviously I don't have anything in my on my servers on disk on my file system as far as segments. So there, I have no data on there. Everything is in memory. So if I were to restart uh, Pinot or just the server, you may not see um, that data coming back. So let's take a look at what happens here. So if I restart, there is a restart target here. What I'm going to do is just restart the Pinot server. This is the server that we've been looking at and where we've deleted the segments. Okay, so let's do that. Make start. So we're restarting the Pinot server. Great. Pretty messy here, but Pinot server is right. Kafka, Pinot. Where's the Pinot server? Here. It's wrapped. Pinot servers right there. And it looks like it's up. Okay. So let's query that data again. Notice that that data, those segments don't exist in that server. We deleted it previously. We restarted the server. Now that flushes the memory, obviously. Now I can't query that table, right? I can't query it, but there it is now. Right, what happened? So we can go back into this list and notice that those events or that those segments got restored into the server from the deep store, right? So you can do this all day, delete, corrupt, etc. These segments. The deep store will restore it. The server will get realize that it's missing some segments, and it'll go out and get it from the deep store. All right. Let's go back to here. So there is a validate section here. Everything is simply really made easy for you to just like make lists to see, recursively list your index directory in your server. You could delete it yourself. You can list it to just verify that you have deleted those segments from the server. You can restart that server, and then you got to wait a little bit for the deep store to to get those segments to recover again. But then after a while, you'll see that you can list them out and then be able to query them immediately. Right? Any questions about this demonstration or about MinIO, or I'm sorry, the deep store and Apache Pinot in general?
While I don't see any questions in the chat yet, let me ask something myself. So, um, So what gonna happen if something will be corrupted on a deep store? Is it like a data loss? What's your recommendations? How to deal with this type of situation? Should we rely on whatever backup techniques available for your object store, or you should do something else? How you go about these type of situations?
The idea of the deep store is that it's going to preserve your good index, your good segments, right? When it gets loaded into your object store, the cloud service, like S3, the cloud service, in this case AWS, will handle any backup or restore. Or it'll handle that side of the disaster recovery. You actually just need to think of the the deep store or your object store or your data lake as a system of record that you could trust, because initially the controller wrote that those segments there, they should be good segments. You shouldn't go out and modify them. Then you will put yourself in a bad state. But it's a place for you not to be like playing around in, is where the controller can ensure that the segments are clean and sorry, I got to reshare my screen now.
Okay.
Where your segments can be clean and can be restored throughout the other clusters, right?
So with this functionality, it's actually a pretty cool piece of functionality that only preserves the data. What about some of the metadata? Is there any way to back up some of the controller information? Or usually people also get confused when they talk about this stuff when saying, "Oh yeah, that's solution for backup." Yeah, but what about metadata? Like the controller metadata, the segment placement, replicas, and all these kind of things.
Yeah. There are multiple places where those things can live. Typically, metadata is subject to uh, race conditions. Like in distributed systems, you have to make sure that they're consistent across the entire system, right? So things where like Raft and like Zookeeper come into play, where you need to make sure that that metadata is consistent across multiple instances. So those aren't things that you would put in the deep store necessarily. You can if you'd like, but in this case, we're using
But there's no out of the box tools that can do that. It's kind of something that you need to do yourself, kind of like a backup Zookeeper
right,
database, for example.
right.
Okay, makes sense. There's a question from the chat. Let me try to put this here. So Robert's like asking, in which case would you use MinIO over S3 or other cloud object storage?
Yeah. So S3 is a really easy cloud data lake for you to use. Uh, but understand it is multi-tenant. Um, it is in the cloud, where you have to understand that you have to trust it. MinIO is actually an alternative to that. If you would like to have your data hosted locally closer to you, where it's protected and encrypted in the way you would like it to be
Yeah, when we say in locally, it means that in your data center
in
somewhere,
your
not
data center.
locally on your computer, obviously.
Exactly. Exactly, in your data center. So that would be a reason, especially banks or public sector, where information is really, you are at the end liable for any breach on that data. You may want to control it at that level by using something like a MinIO locally.
But keep in mind when you need to maintain MinIO yourself, another piece of infrastructure that you're maintaining. So
Right.
in some of the cases, it might not be um, it's going to be extra things
Extra
to
work.
worry about.
Yeah.
Yes. So when you said about like data lakes, uh, so those segment files, are they somehow queryable? Can we store them in particular format that was suitable for, the ingestion into data lake somehow? So for example, can those segments be in the format that like a parquet or something like that? um if we're gonna be using deep store as a kind of like a step for data lake, what do you think?
So let's make sure that we know that the deep store is not in the query path. So that's really important to know. So it lacks a lot of the metadata. For instance, the indexes, they're not serialized with the segments in the deep store, right? Um, so from that perspective, you can't really query the content from the deep store directly. Even if you were going to code it, it lacks some of the information that you would need to like indexes specifically to query it. As far as Parquet, understand that Parquet doesn't hold indexes, right? It's a nice way to um, you know serialize data in a columnar format
Mm-hmm.
on your data lake. In fact, like your iceberg and your delta uh, lake houses are able to consume Parquet just like that. Just like Pinot can consume Parquet, it's a way to share data in a columnar format. Um, but in order to gain the low latency speed and the high concurrency capabilities of an OLAP, real-time OLAP database, you need the indexes that go along with that. So we consume that data as Parquet and then convert them into these segments so that we add on to the data the capabilities of querying it really quickly.
Okay, so there is another question from Victor, but it's not from me. If you have a segment that is in a deep store, and it's called deep store, it's not deep storage, and its threshold dot time is much greater than it's configured in the table, can I still use this old segment in queries? There's lots of unpack here, right?
Yeah, I'll have to check that. I've never run into that situation. The assumption is that there is a threshold to the data that you have in Pinot. You can make it infinite, or you could have a retention uh, to it. Um, I would say that in a deep store, it'll mimic what a state, the data state that Pinot should have, and restore it as that state if needed. But I'll have to double check on the threshold type. I believe that's how it will behave.
Okay. Um, do you want to also like show anything else, Hubert, or we done with the official presentation part?
I think we're good. Yeah.
All right, folks, one more time. Everything that we're trying to talk here, you can find this in our GitHub repository. If you look into the ways how the Pinot can be used and you look into different use cases, I highly recommend to look into our Pinot Recipes repository. You can find this particular repository, this particular example that we talk about today in Mino real time um, um, recipe. If you have any questions about this, or there's some things that going on that not working or stuff like that, don't hesitate to reach out on Pinot community Slack. Pinot community Slack, you can find this in the Pinot that Apache talk. There's a link. There's a link, the link with the a lot of things going on there, but it's easy to find. And this is very great community where the people can, not only the people who actively working on the Pinot, for example, people from Startree, from Uber, from Stripe, but also people who actively trying it, and they can also share their take on the technology. I like to say thank you for Hubert for presenting this this presentation to us today, and he also worked on the implementation of this recipe. Play around, check it out. It actually also pluggable because MinIO will abstract things out. You can use the same recipe to run in your S3 compatible blob store. So this will work. And yeah, there's some additional questions. Robert Zeig commented to this question from the Victor that um, segments are removed from deep storage after 7 days by default. So, as always, check defaults when you're configuring production ready deployment and things like that. So, I think with this, just one small announcement. If you will be around our social media platforms, we will have another presentation this week for you. We're going to be talking not open source part, but the things what we develop in StarTree, specifically in the world of real time detection of the anomalies. And our colleague and also developer advocate from StarTree, Barker Herman, will join us on Thursday. Check it out, some of the posts in the LinkedIn and the social media. With this, it was Hubert Dolly. My name is Victor Gamov.